Okay, here we go. A couple things you have to remember here. We have a title on our notes, and you have your page number. So this is Mr. McCullum, and we're doing terminating and repeating decimals. We're on page 265. I'm going to highlight that for you. 265 in the book. If you have a book, take it out, take a look at it. The right side you'll see is the same as the book. The left side is our problems. A couple of items here. Essential question: what happens when you add, subtract, multiply, and divide fractions? Fractions is really what we're going to be doing today. We are going to do in future lessons adding, subtracting, multiplying, and dividing them, but for today we are just really going to look at just the fractions and some decimals. Vocabulary: we're going to be repeating decimals. We're going to talk about bar notation. We're going to talk about terminating decimals. Okay, so our first item up is our first example, and they give us a 74 hundredths. They talk about writing this number as a decimal. So we kind of have to know a little bit about decimals. So a little bit of review here. Here's your decimal. And we're going to talk about a little bit of place value here. And the place value that we're going to be talking about is ones place, tens place. That's on the left side of the decimal. The right side, we get into things like tenths and hundredths. And if you ever want to know how that's kind of spelt out, you just basically, you see the 10 and you see the 100, and we just add THS at the end. That's our decimals. This is when we get into decimals. This is when we get into, say, change, cents, and then if you look under things under the microscope, things even get smaller, and we bring it out to thousands and 10,000s and 100,000s and so forth. So things get smaller and smaller and smaller. Right now we just have 74 hundredths. You can think of it as 74 out of 100, okay? Or you can think of it as 74 cents out of $1. Okay, so there's a bunch of different ways that I can look at this, but basically it's just 74 hundredths. So when I write my decimal, there's no whole number. So it's going to be 0, and then I'm going to get 74 hundredths, which is 74. Or you could think of it as 74 cents if that helps you. But notice how that 4 now is in the hundredths place. So that's key, because it's 74 hundredths. And that's how we say it. It's 74 hundredths. You say it here, 74 hundredths. It's the same thing. We haven't changed anything here. These are equal. This is a fraction. This is in the decimal form. So we haven't changed anything. If we go on to number 2, they give you 7/20ths. Well, 7/20ths, well, you know, that works, but I don't have no 20ths here. But I can change my fraction. Just like I can reduce a fraction, I can make it larger. And that's actually not even making it larger. We're just dealing with equivalent fraction. It looks larger, but it's not. If I multiply 20 by, say, 5, I know that I'll get 100. Well, I need to make sure that these are equivalent, so I need to make sure that I multiply the same number to the numerator, which is 7, and I'm going to get 35. So I get 35 hundredths. Well, now I'm just same as 74 hundredths, but now it's 35, so I'm going to write 0.35, making sure that my 5 is in the hundredths place. Or think of 35 cents. So I go ahead and I break out my highlighter, and I'm going to make sure that that's in my hundredths place. Well, 5 3/4 is a little bit different. We call that a mixed number. Well, why is it a mixed? Well, we have a whole number, and we have a fraction. And if you smash both of those together, you get a mixed number. So what if we split them apart? That's a whole number. What if I take 5 and I split it apart using a plus sign, and then I take 3/4? Well, now I have something that I can put in the ones place. But 3/4. Let's see. If you had 3/4 of a dollar, how much cents would you have? Or what can we multiply to 4 to get to 100? 25? Oh yeah, that equals 100. But what if I multiply 3 times 25? Did you get the same answer as how much 3/4 of the dollar you have in cents? Yeah, you'd have 75 cents. Or 75 over 100. Or 75 hundredths. So I'd put my 75 here, making sure that my 5 again is in the hundredths place. There you go. You got your 74 hundredths, you got your 35 hundredths, and now you got 5.75 hundredths, or 5 and 75 hundredths. It's just how we say it. Now it's your turn to try it. Go ahead and try these two. Try 3/10 and try 3/25. Just by converting them to hundredths, and you should be able to write it out. A, you should just be able to write out as 3/10. Good luck. Okay, welcome back. Hopefully you did those okay. Now we're going to change a little bit. Now we're really going to talk about repeating decimals, bar notation, and terminating decimals. We're going to do a little bit of long division too. So we're going to talk about how this 3/8 looks. Basically, we're going to talk about division. Now, if you remember in one of my past lessons that I gave you, I said, well, division was basically my numerator over my denominator, which means my numerator is being divided by my denominator, which means that if I was going to put my numerator in the little house or whatever you want to call it, we're going to divide it by the denominator. All these are the same. It's just today we're going to use this form. My numerator divided by my denominator. Numerator being the top number, the denominator being the bottom number. Well, it doesn't go into 3. But if I take my decimal in there, 8 goes into 3 0 times. Put another 0 in there. Does 8 go into 30? Oh yeah, 3 times. Because 3 times 8 is 24 if you remember your multiplication tables. We subtract. Oh, look at that. You get 6. And then you got to keep on going. So how do we do that? We just bring down another 0 because that's all it is. It's still just 3. But 3 is 3.000000, as many zeros as we want, but that's still just 3. So we just bring down another 0 and we get 60. 8 goes into 60. Well, let's try 7, because 7 times 8 is 56. We go and subtract. You get 10. 10 minus 6, you get 4. Well, let's take one of those other zeros and bring them down because we're still dealing with numbers. Ooh, 40. 8 goes into 40. We know that. 5 times 8 is 40. We subtract, we get 0. That's what we call as a terminating decimal. How do I know that? Because it stopped. Every number after 5 is going to be 0. Why? Because we have no remainder. So write that down. That's what a terminating decimal is. There's no remainders. But when we're dealing with decimals, we don't usually deal with remainders anyways. We just keep on going. And they usually round, or in this case, it terminates. So what's my answer? My answer is 0.375. And that is the same as 3/8. They are equal. Example 5 deals with a -1/40th. Well, you know that negative? I'm going to just highlight it right now. You just have to remember it. Because we're dealing with things that are equal, we're going to write a decimal that's equal, and our decimal is going to be also a negative. But let's set this up. 1 divided by 40. Well, go ahead, throw your decimal in there. We know it goes into 1 0 times. Well, 1.0 is still 1. Does it go into 10? No, not yet. Extend this bar out a little bit longer. Does it go into 100? Sure. Let's try twice. 2 times 40, you get 80. 100 minus 80, oh, that gives me 20. Well, bring down another 0. We got lots of them. We have a continual supply of zeros. 40 goes into 200. I think 5 times 4 is 20, so let's see if that works. 5 times 0 is 0. 5 times 4 is 20. Look at that. We subtract. You get 0. We get another terminating decimal. Okay, so what's my answer? 0.025. Very, very important where my zeros go in my decimal. Negative. Don't forget that negative. If you forget that negative, it's going to be wrong. Our last one, our last example, before you guys go off and work on your homework. 7/9. Same thing. Take that 7, place it in there, and we'll start dividing it out. Put our decimal in there. Decimal up top. 9 doesn't go into 7, but does it go into 70? Oh yeah, 7 times. Because 7 times 9, if you remember your multiplication tables, is 63. Okay, let's subtract 10 minus 3. Oh, that gives me 7. Well, we got plenty of zeros. Let's bring down another 0. Wait a minute here. We already had 70. Look at that. Well, 9 goes into 70 the same amount of times it did before. 7 times, we get 63. Let's see if anything else changes. Well, we subtract, and we get 7 again. Look at that. And you bring down another 0, you're going to get another 7. This is what we call as a repeating decimal. All I ask on repeating decimals is to make sure that they actually are repeating. So don't just do it once, don't just do it twice, maybe 3 times, just to double check. Because sometimes they trick you and all of a sudden it's not repeating anymore, so you always want to check. So how am I going to write this out? If you wrote 0.777, that means it ended. But if you write 0.7 with a bar over the top of the 7, that means it's repeating. And this is what we call as bar notation. This lets me know that it's repeating. You always put the bar over something that's repeating. These are exact 7/9, and 0.7 with the bar over the 7 is exactly the same answer. Okay, so think about it. Anything that's repeating, go ahead and do that. But if you don't put any bar over it, like on number 5 or number 4, then that means it terminated or it ended. Because I'm assuming that 0 is at the next spot after 5, or 0 is after 5 over here. Okay, that's reaches to where you are going to try to do 2 problems now. You're going to get 5/9 and 5/7. If you run into a problem with that bar notation, sometimes it's also ... means it repeats also. So you could use ... Okay, good luck.